Voyager 1, sent into space in 1977, has become the farthest human-made object ever. Today, it drifts more than 26 billion kilometers from Earth, moving through the edge of interstellar space. If you tried to reach it with a signal traveling at the speed of light, it would take over 22 hours just to get there, and another 22 hours for the reply. Almost 2 days for a single exchange. And still, across that unimaginable distance, we haven't lost contact. How is that even possible? How do you communicate across a distance so vast, it's almost impossible to imagine? To understand that, we need to go back to the beginning. In 1977, NASA launched 2 spacecraft. Voyager 2 first, then Voyager 1 just weeks later. They were nearly identical, built with technology far less powerful than the phone in your pocket. And yet, they were designed to do something no spacecraft had ever done before, exploring the worlds beyond. But there was a problem. Reaching Jupiter, Saturn, Uranus, and Neptune would normally take decades and enormous amounts of fuel. Fuel the spacecraft simply didn't have. So scientists came up with something brilliant, a cosmic shortcut. At that exact time, the giant planets were aligned in a rare configuration that happens only once every 176 years. This alignment allowed the spacecraft to use gravity itself as a slingshot. As Voyager passed near a planet, it stole a tiny bit of that planet's momentum, accelerating to even higher speeds without using extra fuel. Voyager 1 reached Jupiter in 1979, and what it saw changed everything. Massive storms swirling across the planet, a faint ring system no one had confirmed before, and something completely unexpected. On the moon, Io, active volcanoes erupting in real time. The first time humanity had ever seen volcanic activity on another world. Then came Saturn, a world of rings, more complex, more structured than anyone had imagined. Voyager revealed gaps, waves, and tiny moons, shepherding the rings into shape, and then Titan, Saturn's largest moon, wrapped in a thick atmosphere, rich in nitrogen, a world eerily similar to early Earth. After that, Voyager 1 did something extraordinary. It didn't stop. It kept going, leaving the planets behind, heading toward the very edge of the Sun's influence. Out there, far beyond Pluto, there is a boundary, invisible but real. It's called the heliosphere, a vast bubble created by the solar wind, a region where the Sun's influence dominates. And then, beyond it is interstellar space, the space between the stars. In 2012, Voyager 1 crossed that boundary, becoming the first human-made object to enter interstellar space. And still, it kept talking to us. But how? How do you send a signal across 26 billion kilometers and still be heard? The answer is both simple and unbelievable. Voyager carries a dish antenna about 3.7 meters wide. It sends a narrow beam of radio waves powered by just 22 watts. That's less power than a household light bulb. By the time that signal reaches Earth, it has spread out and weakened to almost nothing. Less than a trillionth of a watt, and then even less than that. A whisper in a cosmic storm, and yet we can still hear it. Because on Earth, we built something incredible. The Deep Space Network, a global system of massive antennas spread across 3 locations. California, Spain, and Australia, each one equipped with giant dishes, up to 70 meters wide. Together, they form a continuous link, so that no matter where Voyager is, at least one antenna is always listening. These antennas are so sensitive, they can detect signals weaker than the energy released by a snowflake hitting the ground. That's how we talk to something, billions of kilometers away. But communication is only part of the story. Voyager also needs power, and out there solar panels are useless. The sun is just a faint star. So instead, Voyager runs on nuclear energy. Inside it, a radioisotope generator slowly converts heat from decaying plutonium into electricity. At launch, it produced over 400 watts. Today, it's less than half of that, and still dropping. To survive, NASA has been shutting down instruments, one by one. First the cameras, then heaters, then backup systems. Only the most essential instruments remain, measuring magnetic fields and charged particles in interstellar space. Even so, Voyager continues to send data from a place no spacecraft has ever explored before. Over the decades, things have gone wrong. In 2023, Voyager 2 lost contact after its antenna shifted slightly. Just a tiny angle, but enough to lose the signal completely. For weeks, it was silent. Then, as if by design, it corrected itself, and the signal returned. Voyager 1 also had issues. A software glitch caused it to send meaningless data. NASA had to debug a spacecraft billions of kilometers away, and they fixed it. But time is running out. Its power is fading. Its systems are aging. NASA estimates that by around 2035 to 2036, communication will finally end. Voyager will go silent, but that won't be the end, because Voyager will keep going, drifting through interstellar space for thousands, even millions of years. Long after Earth has changed, long after we are gone, it will still be out there, carrying something extraordinary, a message, a golden record filled with sounds, images, and greetings from Earth. A time capsule, and somewhere far in the future, maybe something will find it, and know that we were here, that we looked up at the stars and wondered, and that we sent a small machine into the darkness just to understand what lies beyond.